day everyone. Today we from T28 want to present to you guys about fabrication of PCB, printed circuit board. In this video, we will support with a montage from what we had done in the lab. Okay, first of all, let me introduce ourselves. First, my name is Muhammad Zohizan.
I'm Nasri.
I'm Nazifa Devida.
Okay, we're from FK EE112 Electrical Engineering Power from UITM-PG.
Our topic, PCB layout is a process to build electronic device. A PCB serves two purposes in the construction of an electronic device. It is a mount the component and it provides the means of electrical connection between the components. Since the inventor of the printed circuit was the Austrian engineer Paul Isler, present this method to the world, processing PCB become easier and more product being produced worldwide.
We have to clean the copper on the PCB surface. So we did this because we want to get the best result when we laminate it. Next, laminate dry resist film onto PCB surface. When we do this part, we have to take a few precautions, such as we must do it in a dark room because the film is sensitive to the light. If this film is exposed to the light too much, so the blue color will be broken and make that result to our board.
For process 3, artwork has been transferred onto PCB copper surface by using UV exposure for 50 seconds. Wait until the light went out and open the lock. The machine acts as a vacuum to make sure that the film and PCB surface was closed.
Step 4. Remove the second layer of the dry resist film. Then the unexposed photoresist was removed chemically using developer. Use 4 meter per second for speed and 39.9 degrees Celsius for the temperature. Only 50 seconds was needed to complete this process. In the fifth process, any exposed copper was washed away over the board. Use 1 meter per second for the speed and 44 degrees Celsius for the temperature. In this process, the copper was removed from the PCB surface using ferrum 2 chloride solution.
For the process 6, all the photoresist had been removed from the board after let it be in the Frota spray in 26 degrees Celsius for 2 minutes and then the circuit has been rinsed with water.
The board had been drilled by using 3 mm for corner fixings, 1 mm for some holes that needed to be the connectors, and 0.8 mm for all other holes. PCB rubber was used to clean the copper. Use the laboratory glasses to protect the eyes from the dust. did experiment 9, we faced a few problems, such as the emitter did not give us any record for the current value. This is because we connected the circuit wrongly and used the wrong emitter. The emitter should be connected first, then the resistor, but we connected it the other way. We were supposed to use the emitter, but we used voltmeter. Therefore, we changed the connection and used the correct emitter. Hence, we got the correct reading. Next, we did not know how to arrange the circuit after converting the schematic diagram design to PCB layout. With the help of the lecturer, we managed to finish our task perfectly.
When we did experiment 10, we learned about PCB fabrication and LED blinking. We knew how to get a perfect PCB fabrications. We also knew all the steps for PCB fabrications and the precautions while doing this experiment. We knew that LED2 was blinking because of the programming that we had programmed in the IC when we did experiment 9, while LED1 was light up because the circuit has connected completely to the light and ground. Even though the IC was not connected in the circuit, LED1 could still light up because of the input 9 volt. LED2 will not light up and will not blinking when we did press the switch, as the switch will disconnect the electric current from the circuit and straight to the ground.
At the end of this experiment, students understood the basic concept of simulation and circuit design by using Proteus design suite software. Although the steps were complicated, the student could do it with some help from lecturer, and it was convenient for students to make a design for PCB. This software also helped the students simulate interaction between microcontroller and analog or digital electronics circuit. When the schematic diagram design was done, the student transferred it to PCB layout. Other than that, the student learned the process of PCB fabrication, starting from the cleaning the copper on PCB surface until the soldering electrical components to the board. All of the steps needed is to do it carefully and follow the flow to make sure the PCB not broken and be in a good condition. After the soldering, students have to check all of the connection, either they were connected or not.
Go!
Lastly, students knew the proper tools used in PCB making and always apply all of the safety requirements to avoid any accident that can be happen in the lab. Hence, all of the objective was achieved. Thank you.